part of our cloudification and full digitization of the teleport. So one of the key points is the ability to orchestrate and to automate the platform. As a result, our customers can gain advantages of fast deployment, time to market, an easy way on getting from zero to a service where in the past we had like a week to 2 months, depending on the size of the platform. Now you can go in minutes because the whole workflow is automated. So that's an advantage for our customers, and the end customer can immediately gain advantage of that. You can have end customers, our enterprise customers that have an outside plant, mining, they want to have a connection to cloud services. Well, now it can be done like in minutes time frame on deploying both the packet processing as well as the modem into a full software-defined environment. So what's going on is orbit is clear. We get more and more bandwidth available. So we need to be able to scale a network. Scaling the network means again, you need to get access to resources. These days, resources are literally available in the cloud, on premises, in data centers. So the drive for software for us is like taking off the monolith and go to microservices, being able to containerize your data paths, your network functions, your baseband functions into a full containerized world with an automation orchestration layer on top. That's key. So it's from being in the industry, having the most flexible, spectral, most efficient platform. Well, that's we're going to adopt to the software-defined environment by fully cloudifying the environment. So the area it's a given. Our control plane, our NMS is already cloudified today. You can deploy that on-prem and in the cloud. Our next journey is taking our packet processing and run it in a fully cloud native environment. That's actually what we have announced yesterday with Microsoft Azure in the next step, next to the software-defined modem, to also deploy the network packet processing and then build on top of that. The next step could be the virtualized modem, which has its own complexities with regards to throughputs on the cloud, with regards to the models, CPU versus traffic. But that's like the last step in the, we'd call it, economical scale of the platform. So network processing, the first one, getting into a hybrid environment with our baseband, that you have immediately access to a variety of teleports from one central point. I'll talk first about the end stage. And the end stage you can actually see on this diagram, right? We have a variety of modulators, demodulators, typically, an appliance-based module. Now working on our next generation modulator that is in fact the sum of all the best we can get of our current portfolio, but enabling the digital world. As you can see here, we enable that particular appliance with a high-speed Ethernet interface so that we can do radio over IP. The ultimate goal is to go all IP from the modulator onto the antenna, but it's going to be a journey, right? So today we have the L band, lots of complexity, RF levels, making the signals redundant, lots of complexity. If you put an IP layer in between, it's all like standards IP compliant. IP vendors, switch vendors have this under control, so we partner up with them to have like a full, reliable radio over IP network. The critical element in that ecosystem is the modulator, as well as what are we going to do on the digital side of the antenna. For that we have a roadmap. So you'll see as part of being member in the DIFI consortium, actually we're driving the standard forwards together with the partners in there. We've proven a first demonstrator where we are interoperable with the 1.1 spec of DIFI, having an interop with a digital bug vendor, showing that we master that technology. I think like in next week or the week after, there's a big plug fest coming where we show our next steps. The next step is like a fully digital path, all the way from the modulator, the digitizer, and then back to the L band to catch the traditional antenna.